I need a cup of tea. That's what's wrong. You know what, let's just write some code and see what happens. This is the bit that they never show you in videos, where the person making the video is sat for 5 minutes thinking what to do next because they are literally making the thing in front of you. Hey there, welcome back. So this is something new that I'm trying. It usually takes me quite a lot of research and time and sitting at my computer writing code to make the usual programming videos that I do. So I'm going to try a few other ideas. One of them is the ST repair video. So I'm going to do a couple of them and I can slide those in amongst my other videos that are going on. And I'm going to try this as well, where I'm trying to do some coding. This thing whirling away here is a Raspberry Pi compute module that I've installed Raspbian on, or do they call it now just Pi OS or something? It's Ubuntu. And I'm trying to learn how to write little games for it using SDL2 and just straight up C. So no C++, no OpenGL. Most of it is generally pixel-based graphics. What I'm trying to do is figure out how to write little simple games. Things like you would have seen in DOS. So this style of game, where it's just sprites and tiles and nice basic things, and you can focus on actually making the game work. Or games like this. So you see it's got this kind of same basic, quite low resolution, not many colours. I can kind of cope with this level of art. I'm not an artist, so I can probably manage this. Here's another example of the kind of thing that I'd quite like to make. So the general idea is that over however long this takes, I've got no set time limit, I want to make a little game engine where I can make basic sprite-based games. The sort of thing that you might see if it was the 90s and you got an Atari ST and a PD library, or you got DOS. I quite liked it back then when you got a cover disc on a magazine and it had some random games you'd never seen before. And most of them were rubbish. But I bet the people who made them had a lot of fun making them. So if I can make crap games, I'm going to make a few crap games and have fun doing it. And you can come along for the ride. I'm not doing this on my PC, running something big like Unity. This is my little Raspberry Pi compute module. It's running in 1280 by 960 or something. But the screen resolution I'm targeting, if I run the code again, is 640 by 480. So what you're looking at up here is a 640 by 480 display. Now the things I've got working so far are all the quite tedious and slow background things that don't really look that interesting. So in here I've got various pieces of code for loading in a font and printing the font on the screen. And some really exciting code, where is it? For finding the minimum and maximum of two numbers, okay? Printing the code involved rewriting printf to copy pixels instead of text. So I also had to write a blit function. There we go. Copying pixels about. It's what I've spent the past sort of week doing. And the end result is I now have a core game loop. So I have a game loop that runs at a fairly steady 60-ish frames a second. It can draw lines and rectangles, and I've managed to bodge it so that it can draw a little animated character. I'm not making all this stuff up myself though. I am doing quite a lot of research in the background to find things out. So I've been using this website quite a lot to remind myself how SDL works. I've used it loads before, but I keep forgetting and having to relearn it. So this website's quite helpful. This is another website that I've been using to get a game loop that actually functions at a decent speed and doesn't go mad on different speed computers. Right, so what we're going to work out is I have this little dude, and at the moment all that he's doing, it looks like he's doing quite a lot. It looks like there's animation and there's a sprite on the screen, and we're halfway to making something decent. It's a bit of a trick. Let me find the code. You'll notice I've got quite a lot. I'm trying to organise this code so it's understandable. There's separate header files for pretty much every function. Okay, so here's the main code for drawing things on the screen. First I clear the screen, then I define two rectangles. So this first rectangle is where that little dude on the screen appears. He's appearing at 40, 50. And the second rectangle is just used for this moving frame counter thing that's bouncing around the screen. So I've got a timer that every 10 frames, it just advances which part of the graphic we're showing on the screen. So if I look in the list of assets where that's gone, there's my little dude on the screen. He actually looks like this. So all it's doing is displaying each one of these in turn, one after the other, on the screen. And that's all it's doing. There's no storage of where that character is on the screen. There's nothing else happening. So what I'm going to do is create a little sprite system. This will probably mutate into some giant all-encompassing sprite management thing with state machines and different sections for players dying and coming back alive and all that carry on. But at the moment, I just want to get a couple of those on the screen moving about independently. So let's have a bit of a think. There are several things that I'm going to need. And let's go into the right bit. So let's make a new folder. And in there, we need a definition of what we're storing about each sprite. Right then. So what does it mean to be that little character on the screen? What are we even going to call it? I think the overall thing can be a sprite. That can be the unit of game that is on the screen with the data about it and its little image. We need to keep track of where it is, so we need a position. I'm using an SDL rect even though it includes a width and a height, simply because everything uses it. I could use an SDL point, but then when I pass this into a routine that wants to draw things that uses a rect, I'll have to convert that into something else. So we'll keep it for that. We also need a hitbox, which is going to be the collision area within inside the sprite. Right, another thing we need to do is know whether it's active, as in it's being used by the system. So that can just be one of those. And we need to know if it's visible on the screen, because it could be invisible. Now we need its graphics, but this is going to be used for an instance of each sprite. So I don't really want to have many loaded copies of the same graphics everywhere. So instead, we'll do that. Right, later we'll need something for updating the sprites. So we'll need some sort of function pointer. Because no, we're not using C++, but we're putting functions inside a struct, which is sort of how C++ really works. But this is not C++. Right, so I think that is the data we need about a sprite for now. I'm not entirely sure if it's correct, but it's a starting point. So we'll go with it. Right, I need a sprite manager. I don't like the term sprite manager. I can't think of a better name for it though. It's a thing that manages the sprites. It will do. So let's go into the C section. New file. Sprite manager.c. We need you. Whoops. You're not bad Visual Studio Code, but you're not as good as proper Visual Studio for your tab completion. Right, so we need a list of sprites. So what I'm trying to do is slightly replicate a different system that I've used So I'm trying to think bigger than just making little games for my Raspberry Pi. Because I've got this, which is one of those suspicious Chinese multi-handheld game things that emulates a dozen old systems. And this can emulate a Game Boy Advance. And I can find Game Boy Advance C compilers. This weird little thing is called a 32-bit, which is a little kick-started handheld, and I can write code for that using C. This is my 2DS with one of these little R4 card things. So I can write code using C on this. There's a bit of a pattern appearing here. And just over there is my Spectrum Next. All these systems have the same thing in common. They all use quite low resolution screens, limited number of colours, and they're not powerful enough to make huge games. Like, I've decided arbitrarily to have 100 sprites on the screen at once, because that's what these systems can kind of cope with. Any more and they're either hardware limited and they can't do it, or they just slow down too much. So this should stop me trying to make some massive game that I'll never finish, because who wants to spend 5 years of your life making one little rubbish game that 6 people are going to play? I'd rather make 100 rubbish games that 6 people are going to play, and eventually get semi-decent at them. So we're going to have 100 sprites. That'll do. We now need some functions for loading sprite sheets in, creating new sprites, and drawing them on the screen. At the moment, I've got a little guy on the screen with different animation frames. And all that's happening is up here, I'm loading the image, then copying sections of that image to the screen. That's all I'm doing. But I know where he is, and I can advance the image being copied. So let's at least replicate that and see if I can get 2 of these things stomping around on the screen. So I need to create a sprite first. And creating a sprite just means finding an empty one of these and setting the data. So first we need an init function. Ooh. Where is it? We can use slightly better things for this. Is active can be an SDL. Bull. You can as well. This is C. There's nothing fancy about these things. They are integers, really. But, you know, oh, this says it's an enum. Let's have a look. Yeah. So, false means 0, true means 1. It's an integer. It just makes the code look a bit more obvious. I like self-documenting code like that. So we'll start off initializing the system by just making all the sprites inactive so that I don't see anything on the screen. Let's have a draw function. Now we need to know where to draw them to, which is a common problem in game engines. There's always something representing the screen, and it's either a pointer to the physical screen or some handle that accesses lower bits of the system. And somehow you've got to pass that all around your code. So the way my game engine works is I'm trying to avoid hard coding things into it. So there is a config file, which it loads in when it first starts up, which is up here. Here it is. So it's got a system font, the height and width, and a title for the window. I'll add more things to this as we progress. But the idea is, some of the hard-coded config data is not in the code, it's just in a file, and I can read it out. So when the engine starts up, the first thing it does is it will load the config file. It puts all that into a struct, or an instance of a struct. And it's got 2 parts to it. It's got the data read from the ini file, so I can keep referencing that, like the width and height of the screen. And then it's got global data. And these are things that bits of code everywhere need. Like, I need to know what the screen is to be able to put things on it. I need to know timing of the game. I want to know the frames per second to display it on that little frame counter that's popping around the screen. Okay. I've also created some macros so that I can get to those without having to type all this out every single time. And accessing this is dead simple. I just include this header file wherever I need it, and this line of code makes sure I've got access to that piece of data. So in here, we also need to include the config. It's in core engine config. Right, so drawing just involves going through the list of sprites. If it's active, right, if we're using the blip function, we need to include this. And it's not going to be dude. It's going to be sprite I dot image atlas. Not going to be R3. It's going to be that's I dot. Now let's just go back to the definition of this again. You see, I said here that the position is... No, that's fine. Right, so what I need to add is another rect. And I need to say that is the current frame rect. This is going to be the thing that lets me decide which part of it to draw. Right, I think it'll help if I document some of this, or I'm going to forget what's going on. So, this is where on the screen it is. This frame count, I may end up not using it, replacing it. This is just a basic idea. So back to generating code. So we've got that, we've got that. So we're going to use the current frame rect. Okay, I'll try the address of it then. Got the screen surface, and R1 is where we're going to put it. And then 227 is the transparent color. Part of the reason I'm writing a lot of the code by hand is that this is simulating an 8-bit per pixel palette-based system. I had quite a lot of fun trying to find a decent palette. I found this quite nice website. Let's just see if I can find it. There it is. So there's this website here that's got lots of palettes on it. This is the one I've picked for my engine so far. seems to have a decent spread of enough interesting colours that I can make something. You see, normally these palettes, they follow things like this, which is, they just seem to have too much red in them. Like, there's a couple of greens, but mostly it's reds and oranges and blue. And they just don't seem to have decent shades. So I think I found one. That's quite nice. Don't mind that. Quite a simple thing that looks a bit BBC Micro. So yeah, colour 227 is transparent. So drawing it should just split the thing to the screen. What I've done in it does that. Right, let's try and create one. Now this is going to need a load of variables to define it. Oh, these all should be void, because they don't return anything. This can return false if it doesn't work. Yeah, like that. Right, so we're going to need to know where on the screen it is, what it is, and its image. Right, I'm trying to be semi-consistent in the way I lay out bits of code so it doesn't trip me up. So if things are having underscores in them, functions start with lowercase letters, variables have underscores in them. You'll probably spot there's a few inconsistencies. I'll get around to fixing those later. It also means I want to have the kind of common thing at the start. No, that shouldn't return a bool. That should return an int or a one of those really, for which sprite it is. So to create a sprite, I will need to say where it is. We'll just do it like that. Then we need to know, see in the position, I can also store its width and height as well, because I'll need to use that for other stuff. Although it can be stored in there as well, I don't know. Right, so we know where it is. We need to know what it is. Now you see, now I'm mixing up an instance with a definition. Shouldn't be passing the file name in when I'm creating a sprite. I should tell it what sprites exist and then create instances of them. So this is slightly wrong. We're going to call that a sprite instance. We're going to make a new one. I'm going to call this a sprite definition. Right. In a definition, the hitbox is going to be the same for all sprites. The image atlas is going to be all the same. That's not, I don't want that. That I don't like. So we need to know which definition it is. Right, so I know what kind of sprite it is, I know where it is. So that means in here, I need to have right, so this can be how many different types of sprite we can have, which is different to how many instances of every sprite we're going to have in the game. So max sprite definitions, arbitrary number 64. That'll do. 64 different types of sprite. I don't know. You can always change it. Doesn't mean anything. Now, sprite instance, yes, sprite instance, sprites. And since I keep getting mixed up with this, we'll call it sprite instances. Make it nice and separate. And And we can now rename these slightly better. Sprite create instance. Sprite draw all instances. And that can be sprites in it. How's it complaining about that? Nothing wrong with that. Oh, okay. Get instances. Right, some of these are wrong, but we'll fix them in a minute. Let's worry about creating it first. Right, so if I'm creating a definition, that's one of these things. I'm pretty much just telling it what it looks like and how big its hitbox is. Which also means I need to tell it how big its individual frame is. So how big it is, its hitbox, and its atlas. Right. So I'm going to pass all these in as integers because they're going to come out of a file at some point. So I don't want to have to create an SDL rect from data out of a file just to point to this to start in another SDL rect. I may as well do the whole thing as integers and do it inside this function, if that made any sense. And we'll just have a look. So dimension. I need to know its width, its height, its X offset for its hitbox, its Y offset, its width. Oh, I don't like long function definitions really. Its height. And the image atlas file name. Right. Longest definition of a function ever, but never mind. So something I'm trying to avoid doing is allocating lots of memory everywhere. I could just have that as pointers and dynamically allocate a new structure every single time. But another thing I'm bearing in mind is at some point I might be porting bits of code to things like this where there is very limited memory. There's often not a memory allocator in the C library that they use. And you certainly can't go around just asking it to create lots of things in one go. So instead, I've defined a static list of memory to fill up with these definitions. And I need to know how many definitions I've currently got so that I know where the next one is. So currently none. This saves me having to search through this list to find a free one, and somehow recording that it's not defined. So now we can just go sprite definitions, definition count. Well, we should probably do if we'll return it. If definition count greater than or equal to sprite definition return 0. No more room. Just because I know it'll turn up at some point. Let's include a bit of debugging. My keyboard is quite nice, but it's an N key rollover, so I can literally mash the keys and it records every single keystroke. So if I press between the keys, it puts them all in, and my typing is quite sloppy. So I expect lots of typing mistakes. There, let's have that. Dot image atlas equals. We did this code down here. Image load. Right, I bet you don't know what image load is, do you? That in. Right, no, let's return -1 for errors in this, because it's going to return the number of the definition, which could be 0 upwards. So -1 in this one for an error. So if we get that file, we've loaded it. That should work for that. Got the width and the height. Got the height. No, that'll define one. Seems fairly sensible. So we'll put you into there. Is this distracting? I can turn this off if it's too distracting. I kind of ignore it. It's actually whirling away on a screen to my left. But it's been doing it for so long I've kind of got numb to it. Right, we've defined that. Initializing the sprites is a thing. Drawing all the instances is going to be a thing. But it's not this. Right, so let's go back down to here. So we're creating an instance. We need to know what instance it is first. Then we need to know where to put it on the screen. can work that out. And we need to... No, we can work that out as well. Right, this is much better. Yep, I like this more. I was getting annoyed that I had to have so much stuff just to instance a sprite, but I don't. I do it separately. I tell it here what a sprite is, then later I just tell it to create an instance 3 at this position, and it's done it. I'll fix this in a minute. I just need to get on with typing out some code here. So creating an instance requires us to find a sprite that hasn't yet been activated. So if sprite is active equals false with 2 equals. This isn't my first day writing C, you don't get me with that one. Got more exciting bugs I'm going to be making. So if it's false, we're going to do that and we're going to break out the for loop because we don't need to find anything else. We're going to, no, we won't do that. We'll return I. Or we'll return -1. So if you create an instance and you get -1, it failed. Otherwise, it'll return the index of your sprite. Returning out of a for loop like this always seems a bit messy, but I'm sure the compiler works out the things in the background to tidy that up. Removing half the stack. Right, so what do we need to do? Creating an instance involves setting various things. Well, that should be a pointer to begin with. That just saves me having to look up one thing from another. So, sprite instances. We call it sprite instances, right? Right, instances. Dot is active equals SDL true. It can also be visible, so at least I can see it. Then we'll set the current frame to 0, even though it doesn't really do anything. Definition is going to be sprite definitions instance ID, which possibly needs one of them in front of it, but we need to check that actually. So it needs to be greater than or equal to, because at the end we increment it by 1. So we met the first one, and then it becomes 1. If they pass in 1 and I've not created it yet, I need to know. And if it's 46, because they've typed stupid numbers in. That as well. Hopefully they won't type in negative numbers. I say they, it's me. No, I'm sure it'll be fine. I'm sure that'll only cause a bug I'll never find for weeks. Right, if it's greater than that, we are just going to we'll do that. that. Current frame rect can be 0. Its width is going to be the definition's width dimension. Do I need to store that data? I don't think I do. You see, I originally had that so I knew which piece to copy onto the screen. And my idea was that I'd just increment the X and Y position to copy the next bit. However, my sprites are going to be a single strip. So all I would have done is increment the X position by the width and check I'd not gone off the edge. But in the definition I know the dimensions. So I don't need to store it again. I can calculate it. Because I know what frame I'm on. I'm on frame 0, it's the first bit. So I don't need any of that. It's nice, I'm storing less data. So I've got where it is, got what it is. Okay. It's current frame. So I need to blit the... This is where these nested things get a bit dodgy. Dot definition image atlas, and then we need an SDL rect for its source rect and its destination rect. Right, well, let's make them. So the X position is going to be... No, let's not do it like that, get messy. Well, sourceRect.y is always going to be 0. The width is always going to be that. Height is always going to be that. So it's just the X position. And that is going to be the current frame number multiplied by, let's do these backwards so I can do less typing. Multiplied by its width. Is that the correct maths? It's frame 0, it's 0 times 20. 2 times 20 is 40, which is 1 times 20. Yeah, that's right. I know maths. Right, where did we put that? Source rect. And we've got the surface. Now we need to know where to put it. Right, well. That's just going to be something I feel I've already got. Yeah, position. Don't need that. Go away. Right, I think if I've got it right, this is it. Create a definition, init, draw all instances, create an instance. Oh, no, we can't do that, can we? We need one of those because it returns -1. Yes, let's just paste over you. Bang. Right. Draw all instances is void, init is void. Create definition is all that mess. We're hiding these out the way so that nobody has access to them. I need to go into my make list and include sprite manager.c. Do that. In here, let's include it. Like that. Right, let's see if it works. So I have an init function. We're not going to load the dude. I want to make stuff like this. This looks quite fun. This is X screensaver. It's got lots of weird things in it. It's quite useful just to have it running in the background. I'll occasionally see things that are quite, like, either really distracting and I can't stop looking at them, or they just have quite nice ideas. You'll also notice the screen, the refresh rate drops when it's trying to do 3D. This is a little Pi 4 compute module. Its 3D is not that spectacular. Right, in it, we need to do the sprite manager in it, don't we? So that really should be done by the core itself. So I'm trying to avoid having to do lots of boilerplate code. This is the main program. Doesn't do much. It sets up the game core, it initializes the game, and then it runs the core. So I don't want to have to start a new C file. This was always what annoyed me about making anything. I'd get one example working really well, and then I'd want to make another one, but I'd forget which bits of code I needed to copy, and it just became too much effort that I'd stop. I'm quite lazy like that. I like things to be simple. He says after he cooks up all of this. But yeah, this is a single file. The stuff in here is related to just this specific game thing that I'm making. Right, so yeah, we're going to put the init inside the engine. So, engine core. Oh, I need a name for this thing. I don't know what to call it. I'm crap at naming stuff. It's currently called SDL test because I can't think of a name. If you can think of a decent name for this little retro-inspired game engine thing, please tell me. I might use it. Core setup. Core init. This is where it should happen. So I've loaded all the system fonts and stuff. We can do it here. Init the sprites. So in this init function, let's create a definition for the little spritey dude that we've got. So sprite create definition. Right, he is 20 wide by 20 high. His hitbox starts at 00, 2020. His file name is dude.png. Let's keep track of that. Like that. Now let's try and create some. So, sprite create instance. Dude sprite. We'll put one at 100, 100. Oops. We'll put one at 200, 200. And we'll put one at, I don't know, 67, 400. So that should make 3 of them. Now again, in the draw function, I don't want to draw them. Let's just get rid of that. We'll need the timer. So the draw function should happen in here too. So I've got this core draw function. I call the user's draw function. Let's have the sprites underneath everything that I could possibly draw. Yeah, that'll do. Why is sprites draw not there? Oh, sprite draw all functions. Draw instances, that's why. There. This is all software-based rendering, by the way. All of this. There is no hidden OpenGL. These are not textured quads sliding around the screen that have been scaled. I am literally locking some screen, doing my own 8-bit to 32-bit. Whoops, why is that not working? Declaration. Anyway, I'm doing my own 8-bit to 32-bit pixel copying, which looks up the colour in the palette that I've got. So I'm not even using SDL's own palette section of its surfaces. And then this is the only bit that vaguely uses the hardware, where I present a texture to the graphics hardware for it to put on the screen. And I'm managing it at currently 50 frames a second. That was 60. Why is the extra 10 frames a second escaped to? I don't know. Doom ran at 30. I figure I've got lots of spare computing left over. Right, let's quit you off. Let's just compile it, see what happens. Okay, well, it built. Implicit declaration of blit 8 to 32 in engine core. Why have I not included the right header? No, I haven't. That's why I couldn't find it. That. What else? We're not using R1. No, we're not. Let's get rid of it. We're also not using argc and argv. No. Don't know why we've got those in. Get rid of them. What? Where does blit come from? Oh, it's in graphics. Okay, it builds without errors. Let's run it, see if it works. Let's have a look. This is the fun bit. Let's put some debugging into this. It's got to be calling init sprite create definition. Did we get that far? If we did, are we drawing things? At all? I bet we're not. Let's try again. Right, so we created the definition. Right, so this code's getting called. That bit is irrelevant. Are we setting you to be active? Yes. Right. So we created 3 instances. So it's done this bit. It's drawing them. No, it's not. Okay. Is it calling this function at all? Yes. Yes, it is. So it's saying that it's never active. Go on, what's the obvious mistake I'm not making because I've not noticed because it's 20 past 10 and I'm getting a bit tired. Don't get it. I called create instance. I'm calling that. I'm going through the right function. Right, let's try and work out what's going on. Why is this thing not working? See, it's calling this draw instances. But then let's just do something really daft. It's active. Right, is active equals 1. Okay. This is going to make a really big mess, so let's just quit immediately. Should print out like 100 of them. Boop. Oh. What? See, these are the kind of bugs that plague you for hours. Because something isn't right. And I don't know what it is. You see, I set the instance down here to be active. By the time it gets to here, it's no longer active. When does sprite init get called? Is that the problem? That gets called at the end of there. When does my code get run? My code gets run there. Code go. Let's just look. Okay. So the cause init function gets called here. My init function gets called first. That's not right. I need to give it my init function so that it can decide when it gets run. So we will do it there. Okay. So I need another function here. Right, so type def void start init func void init func user init. Come on, save it. Thank you. Then we'll have an init func user init func, one of them. Hate it when tab completion misses the point of what I'm doing. Right, got that. Core init calls sprites init. Core init can then call user init func, which is this in here. So that should now be correct. Let's get rid of that. No more spammage happening. Will it work? No, it crashes. Oh, it crashes because I made it quit. Where did I put that? There. God's sake, let's try again. Hey, it works. There. That'll do. I've achieved something. Right. So there we go. Managed to make a sprite routine. Isn't that fun? So what I've got now is the ability to create more sprites with quite a lot of ease. Let's just quickly swap this bouncing thing to be a sprite, because we don't really need a frame counter bouncing around the screen with a line joined to it. Let's get rid of the line. Right, so R2 is the line. I'm just going to take this, put this at the top. That actually, that's kind of documentation. Right, so if I rerun this now, it should just put the frame counter in the top corner. Okay, there we go. So that can just sit there. I might make the font smaller. It's a bit big. I'll do that later. So now we need to make one of the sprites move around the screen. So I'm going to use the dest thing that I've got, which is here. So okay, we need a new function, because I can create a sprite, but I can't do anything to it. It appears at this screen location, and that's all I can do. So let's go in here, and let's have a new thing. Sprite set position. And we need an instance ID. To make writing it easier, it's going to accept an SDL rect. Because I'm most likely to pass those around. I've got one there. And I don't like it when you have to do dest.x and then dest.y. I'd rather just pass that in as the whole thing. Then all we need to do is that. But it's not instance ID, it's going to be sprite ID. And we're going to be really lazy. We're just checking you can't go bigger than that. There is probably a better data type that makes that redundant. I'll deal with that later. So now all we have to do is this bit. Now the way this engine works, it has an update routine and a separate draw routine. We need to put the moving of the sprite into the update routine. I need to know which sprite I'm talking about. It doesn't really matter. Let's go for the first one. We'll pretend the first one is the player. There we go. Now we can use that in there. And for that we want best. Right, let's build it, see if it works. No, it doesn't work. What have I done? Oh, yep. It's not I. Sprite ID. What's you complaining about? Oh, it's working. Just need to fix a compiler warning. Oh, I've not returned anything from that because it's an int. There, that'll do for that. Right, so there we are. We've got a sprite bouncing around the screen. So there's animations to do. You can see there's like various poses with the sprite. They are defined really nicely in here, and you can just select parts of them, give it a tag, and then when you export a sprite sheet, once you've exported the sprite sheet, you get a JSON file which contains all the definitions. So it tells you the frame and where it is, which I don't need. It tells you these bits. So there's a frame called loop that goes from 1 to 3 and it bounces backwards and forwards. There's a layer, we can ignore that. So I will need to write a little Python program to pass through this and turn some of this into data I can use in the data that I can use in the sprite engine. That'll be something else. So one last thing before I go, I need to sort out my source and keep it in my own private Git repository. And I have a bit of issue tracking going on. So some sort of sprite system is what I've been working on. So you can see you need to keep the sprite positions as floats, convert them to ints, work out what a sprite is, what we're calling that. Well, we've sorted all that out, so that is bug number 2. So hopefully yep. Right, if I've done this correctly, when I commit this, it should shut that thing. Oh, I referenced it from the commit, but it didn't close it. Should have done. Oh well, it's linked it together. I need to track what I'm doing between issues or I won't remember where I'm up to. So the next thing we need to do is that's what we're working on next time. So if you want to come back next time and see me working on trying to make this engine a bit more complete, come back later. And until then, I'll see you later.